This is a chatbot-style web application I created from scratch using a FastAPI backend connected to an OpenAI assistant, whose search scope has been customized with a vector store of personal files, and a frontend built with Angular 18 using a modern NgRx store architecture. In this case, I've configured the assistant to act as a meal recommender: breakfast, lunch, dinner, sauce, or dessert. I select the type of meal I need, optionally add preferences, and submit the form. The frontend sends the request to the backend, which processes it through the OpenAI assistant. I get a well-formatted response and the sources, the files where the information comes from. Since it's a chatbot, I can continue the conversation. For example, I ask it to replace chicken with beef, and it responds coherently. I've merged three atomic pipelines: design, development, and deployment into a single pipeline that I now share with you, so we can accelerate the development of AI-powered chatbot prototypes more efficiently. Step 1. The project design in ChatGPT. Start by going to ChatGPT and writing the problem context, the desired user experience, the tech stack, architecture, and constraints. Then I ask ChatGPT to turn my raw idea into a professional software requirements document, ready for engineers and generative AI code tools. Step 2. Code generation in Grok. With the refined requirements, I go to Grok. I paste the ChatGPT output, and in return, Grok gives me not just the project folder structure, but also the code snippets using updated libraries. In the diagram, you'll see something called S.E everywhere. That stands for software engineer. That's us, because AI will never replace software engineers. It exists to handle repetitive work, but quality and security will always be our responsibility throughout the software lifecycle. Next is backend development. The repository is linked below in the description. It serves as a solid template for any chatbot project. I chose FastAPI because it's extremely easy to understand and configure. We head to platform.openai.com, create a free developer account. You are only billed by API usage, and there is a generous free tier. We create an assistant either via code or through the web user interface. In this case, I created Grandma's Meal Assistant. I write its response instructions, its personality, enable file search, and upload the files, extracts information, and stores it in a vector store. Step number 4. Backend logic and threads. Back to the backend. Each user request creates a coroutine in the same server thread. In this case, the recommend meal endpoint calls the OpenAI Assistant client, configured with an API key saved in the .env file. The client creates a new thread. This is how OpenAI currently, as of April of 2025, manages context. One thread, one conversation. We add the meal type and user preferences to the thread as a message, and wait for the response. Since this is an async operation, we use polling with Asyncio, which allows the server to handle other requests instead of blocking. Asyncio.sleep1 tells the server, go do something else with the other coroutines and check back in 1 second to see if the assistants already replied. Step number 5, API testing. We can test the endpoints with the built-in Swagger user interface. Just go to the development URL of your backend and add /docs. You'll get a Swagger interface like Postman or Insomnia. Or if you prefer, you can use Postman or Insomnia directly. I already made a video explaining how to use those tools. Check it out after having finished this one. Step number 6, version control with Git. It's critical to manage your code with Git. I love using GitKraken. It handles commits, pushes, pulls, merges, and shows a clean visualization of the Git flow and collaborators. I also made a video on how to use GitKraken. But again, watch this till the end first. Step 7. Backend deployment with Heroku. Once the backend is version controlled and working with OpenAI plus file search, we can deploy it to Heroku. Heroku is a solid, stable, and secure platform. You can create a free account, and usage building is easy to control. Tip: after uploading your backend, go to the Resources tab and set the plan to Eco Dynamics. Groups all your projects into one container and only charges if they are accessed. I've never paid more than $5 a month. Under the tab Deploy, enable automatic deployments. Every push to the main branch will trigger a redeploy. And don't check wait for GitHub checks, unless you have set them up, but that's unnecessary for now. In settings, add your .env variables, like your OpenAI API key. Once deployed, update the local API URL in Insomnia to the Heroku URL and test again. Step number 8. Front-end development with Angular 18 plus NgRx. Now we move on to the frontend. I built it with Angular 18 using a store architecture with NgRx. I've linked the frontend repo in the descriptions and apps about page. It works as a template for any modern Angular project using NgRx for state management, a more intuitive alternative to the dependency injection. Be sure to tell Grok that the frontend must be mobile responsive. This saves you from having to create a separate app in either Flutter, Kotlin, or Swift, which is often unnecessary. First, test the frontend with a local backend and then with the deployed backend. Step number 9. Frontend deployment with Vercel. I deploy my frontends on Vercel. As a full-stack rule, don't put all your eggs in one basket. That's why I keep frontend and backend deployed separately. Plus, Vercel is totally free. Once deployed, copy the frontend URL and add it to the backend middleware's list of allowed origins. Otherwise, the CORS errors will block cross-origin requests. That's all for today. Feel free to fork the repositories and try it yourselves, and use the code as a template for any private file reading chatbot you might need. This is just a first glimpse into an infinite universe of possibilities. If you have questions, drop them in the comments. And thank you so much for watching.